So here we have another differential equations, and we need to solve it by using the method of variable separation. However, if we look at the equation, we have a term on the right hand side which is a function of x and y. So we straight away cannot convert it to a variable separable form, or here we have to make an assumption that 4x plus y plus 1, let this be equals to some variable v, and we differentiate both sides with respect to x, so that will be 4 plus dy over dx equals to dv over dx. Isolating the dy over dx term, so that will give us dv over dx minus 4. What we'll do, we'll substitute this back into original differential equation on the left hand side. So we have dv over dx minus 4, replacing a place of dy over dx, and that will be equals to, so we have a 4x plus y plus 1 whole square, so that will become v squared. So we get dv over dx equals to v squared plus 4, and now we can separate the differentials to obtain dx equals to dv over v squared plus 4, which is simply 2 squared. Now this is in the separable form. That means we can now integrate both sides. Integration of dx, that's straightforward, which is x, and integration of dv over v squared plus 2 squared, so that's a standard form. So we have 1 over a, so a here is 2, times the arctangent of v over a, so a is 2, plus the constant of integration c. Thus our final solution will be x equals to half tangent inverse of, so we have v, so v will be replaced with 4x plus y plus 1 whole divided by 2, plus the constant of integration c.